Thanks for having me here. Today I wanted to talk a bit about how we work in the responsible AI group at Google, and we'll go into a deep dive around how we applied some of our responsible AI practices and innovations on a particular case study and a project that we just announced a few weeks ago. My team's mission is to develop scalable practices around making sure that AI systems and end-to-end systems, not just the particular models, are fully responsible in a whole bunch of different contexts. As such, we focus a lot on making sure that we have responsible practices around our data, how we handle our data, how we collect it. Do we have innovations around making sure to minimize the amount of data that we ever have while trying to create a machine learning model that provides value to users. We work a lot on responsible AI research, which is in the intersection of socio-technical challenges and fields, along with computer science fields, to see if we can bring in the sociological picture into a more definable manner for computer science applications. Today, our mission is to help conduct research and development that is intentionally ensures that technology positively impacts the world. As such, we are a very diverse group of people that conducts a very multidisciplinary approach of research. We have a mix of backgrounds in our group, all the way from people with bachelor's degree all the way to PhDs. We have researchers, UX researchers, engineers, and everybody sitting together to come together to a solution that can balance all the various priorities out there. And that ends up making us one of the most diverse organizations across Google in terms of how we function. So what exactly is responsible AI when we talk about responsible AI at Google? We try to aspire to create technologies that, as I mentioned, benefit the world. But we wrote out this principle, we got buy-in, and we needed to define it further. There was an European Commission communication around how AI systems can have harms, and that communication draft that came out showcased a lot of things around how important it is to exhaustively think about different kinds of principles. And so as such, we detailed 7 of these principles that we published a few years ago. These principles are our guiding light in terms of the very bare minimum that we will always think about when we commence on our research. Some of these include things like avoiding or creating or reinforcing certain biases. In my case study, language models is something that I'll talk about, just like how Genevieve just mentioned, that language models can have certain biases. We try to be accountable to people in our systems so that when the systems work or don't work, they can be redressed in a more responsible manner. We incorporate different design principles and innovations around privacy, especially in different parts of the world. And we uphold very high standards of scientific excellence, which tries to make sure that we have good scientific rigor along the different research that we do. That also includes that a lot of our research, including the things I'll talk about today, are completely open source, published in academia in peer-reviewed journals to ensure that what we are doing is in a stable manner along with the whole community. As such, we have also detailed certain applications that we will not pursue as part of these principles. These include things that are very likely to cause harm. An example that was mentioned by the past 2 speakers include things like credit scores or social credit scores that people might think of to use AI systems for. Discriminatory systems, as mentioned in a bunch of different EU and EC drafts, as well as things that might have surveillance that intentionally violates internationally accepted norms and human rights conventions. We try to, because we also open source so much of our technology, there is this aspect where we have to be very careful in terms of what we open source, because even if we want to be held by these principles and are directed by these, we want to ensure that our open source products and projects cannot be misused. And so we try to ensure that the purpose does not contravene different international laws when we try to open them. So with that context, let's see how we applied some of these principles into a case study that happened for Lambda. Lambda is our models for language models for dialogue applications. You probably heard about it last year at Google I/O, where we talked about a certain chat system that was extremely conversational and human-like. So Lambda is this open dialogue model. The goal of this system is that you can converse about any topic across the world. It has a wide range of potential applications that I'll go into. But as you can imagine, a very good chatbot, in this case, can have all sorts of different ramifications. We started defining that if we have these open domain dialogue models, open domain here in this context is relative to closed domain, which are more vertical oriented. The chatbot that you use to chat with the virtual assistant in your banking app is very different than the chatbot used for maybe your grocery delivery app. Versus an open domain model, the prime thesis or the scientific thesis here is that we will be able to have a system that is a single system that understands both of these, or can be adapted to both of these without re-engineering the whole picture. As such, we define that the responses from these systems should be sensible, scalable, and interesting and specific to the context. I'll go into deeper detail about what each of these means. We want to make sure that the responses are safe. There are certain kinds of responses that can lead to harm by the humans that might be using this. And we want to avoid making factual statements. We have already seen so many different ramifications of misinformation happening, and we don't want to add more noise to this chatter. So the way the Lambda system works is we start with the pre-trained model that learns language without any specific context. It's going through corpora of huge amounts of essentially text, written text across the centuries and thousands of years of human history. And this is done using machine learning models that have a very large number of pre-trained models. You might have heard of similar things coming out of different organizations in the industry, usually under the name of large language models, and this is one of them. The intent is that the model can be helpful in a variety of ways, right? The examples that I gave for open domain include things like translation. You can give it a corpora of different translated documents, and it can automatically understand or help you do translation much faster. It can summarize a long document. And of course, answering information-seeking questions that a user might have. Search engines are an early version of that, but we want to get to a point where we can understand intent even better. Lambda specifically is then built by tuning this pre-trained model. So the way that works is that we start with a transformer model, is what's considered in the computer science industry. And in 2017, we published the architecture of how we went about doing this innovation so that the whole community can approach this. In our NeurIPS paper around attention is all you need. The idea was that if you train a model with this particular aspect of what is the most attentive thing to give, well, attention to, that would lead a model that will automatically improve slowly and slowly across the amount of text that it's reading. The pre-trained model, apart from being large language, it's around 137 billion parameters. To calibrate this, each parameter can be almost a single byte or a couple of bytes, and so this model definitely requires a huge amount of compute power and memory to be able to function, and we still think it is weaker than many human brains. The way it learns dialogue is much more intuitive than we had to do in the past, where because now it has started with this open domain corpora, now we can further train it just by giving access to crowd workers. And so the way we do fine-tuning is this example where we have two particular components of the system. One is called a generator, and the one is a classifier. The generator, for example, for a given response will output a bunch of different kinds of responses and for a given input query. And from the responses, we rank each of them for different kinds of systems, like the metrics that I talked about in the past, around safety, sensibility, specificity, or is it interesting? During generation, we also filter out certain things that are extremely low quality in any of these, and then we further rank them based on the context that we are using them for. These particular responses, the way we trained them, went through crowd workers, which helped tag the responses like, hey, this was specific, this was not as specific, and so on. This helped ensure that the system was starting off with the right boat and people with domain knowledge in whichever particular subject that we were talking about. Different kinds of harms that, like I mentioned, would include things like harm to people or animals just by the textual system. We wanted to ensure that we don't start giving different kinds of advice that is unsolicited, like health, financial, legal, or relationship advice. We don't want to disclose or try to solicit PII unnecessarily. Of course, it should not be obscene or profane in its communication. We also want to ensure certain more implicit things like unjust impacts on people. Discrimination is a classic one. Marginalization of certain groups trying to act superior or inferior, or trying to portray that something is superior or inferior just by language. Insulting preferences of the user is another similar manner in how it can be more subtle but still harmful. And the last one is probably a lot more clearer around misinformation, where it should not try to portray information that does not have good factual corroboration behind it from external sources. This annotated data set is then used for fine-tuning, which is then further taken for evaluation. And that's how we did our full research around how good this system works compared to, let's say, humans. So this is how we performed along, let's say, 6 different axes of sensibility, safety, specificity, groundedness, interestingness, and informativeness. Of course, by no means these are exhaustive, but from along these 6, we, for the same set of, same wide, diverse set of crowd workers, we gave intentionally human complete chat threads as well to figure out the human threshold in most of these. And then we gave systems where Lambda, as you can see, the more parameters that we add to the language model, which has probably happened only in the past decade with compute performance getting that much accessible, we usually see some gains. In many respects of sensibility, safety, and specificity, we are getting close to human levels. Some of the major things that we need more future work on is around groundedness. The 2 lines there in green and orange one is humans and humans with information retrieval. So a classic example is in the informativeness bucket in the bottom right, where a human by default can have a high amount of informativeness if it has access to information retrieval, like a search engine or a book or a library, versus a human without. And Lambda can currently still not compete with humans that have full cognition and information retrieval systems behind them. In interestingness aspects, we find it to be similar enough to many human conversations, but again, it depends on the certain context that we eventually apply it to. And so as such, the different responsible AI research areas within this domain can include, apart from these 6 different things that we rated it for, it goes beyond around the interpretation of safety. In future work, we want to bring in more different concepts and ramifications of safety that go beyond our current definitions. Right now, our current cultural backgrounds and societal context in this group is still predominantly US-centric, and so we want to make sure that it becomes more and more global as we try to figure out different productionized systems that are powered by Lambda. The coarse metrics that we use for harm can still need to be refined further and go beyond each different context. And so this is still early research, and as Lambda progresses and maybe becomes ready enough for some production context, we want to ensure that we are ahead of the game in terms of proactively figuring out the responsible areas that it needs to perform well at. In terms of evaluation methods, we also benchmark across a wide range of different contexts. So we want to figure out different socio-technical ramifications as we evaluate the system and the whole end-to-end system, not just the Lambda model, to ensure that the experience in the end user's context is what matters. Thank you.